Good afternoon, all of you. So, in continuation with our last lecture regarding overview of advanced machining process, today we will discuss the remaining advanced machining processes. So, yesterday we have gone for the laser beam machining, plasma arc machining, electron beam machining, then focused ion beam machining we have seen. Today we will start with the electrochemical machining and chemical machining. Okay, so this is a another process known as electrochemical machining ECM. Okay, so in unit number 4 we have the separate topic about this in detail, that electrochemical energy based processes. In that unit we are going to discuss in detail about this, but here we are going to take the overview of this process. Okay, what is the working principle of this ECM and chemical machine, that we will discuss here. So as we know that, or I hope you know that process called in physics electroplating. Okay, so this electrochemical machining is just a reverse of that electroplating. Okay, now about the electroplating, we know that in physics we already learned. So whatever this electrochemical machining ECM, it is totally reverse of electroplating. And in this particular case, if you see in this diagram, no, then this first one. Okay, in this diagram, in this particular, you have the tool. Okay, you can see here a tool is there. Okay, which is connected to the negative terminal of your DC power supply, and you have the workpiece. Okay, and that is connected to the your positive terminal. Now, your tool is connected to the negative terminal. That means it will act cathode, and your workpiece is connected to the positive terminal. That means your workpiece will act as anode. Okay, and the most important thing is that both that tool as well as workpiece are the electrode material, and they are electrically conductive material. Okay, so please remember this point. Okay, both are electrodes. Okay, that means they have the that electrically conductive property. Now when in between this tool and workpiece, when this electrolyte, okay, electrolyte means what? Electrolyte is a solution of our normal salt, that is NaCl. Okay, and that NaCl we are normally mixing with the water. So electrolyte means the NaCl plus water. So that is actually in our advanced machining language it is called electrolyte. So that we have to flow in between our tool and workpiece. Now in between that tool and workpiece there is always a small gap. Okay, and the gap between these two electrodes, no, it is known as inter-electrode gap, IEG. You can see in this figure also, I have shown some gap. Okay, and you can see the direction of the electro flow, electrolyte. So that gap we have to maintain every time for removal of the material. Now that tool is connected to DC power supply, and that your tool is connected to the negative positive terminal, and in between these two electrode we have the gap, it is called inter-electrode gap, and in between that gap we have to flow our electrolyte. Okay, and once the current start flowing, that time electrochemical reaction will take place. Okay, once, I repeat, once current will start flowing in between or from this tool to what tool, including your electrolyte and workpiece, that means circuit will complete, and in that process electrochemical reaction will take place. Now how that electrochemical reaction is going to take place? Okay, it is similar to our electroplating. Okay, removal of the material, okay, from one surface and depositing on the another surface, that is electroplating. Okay, Na and Cl, that we know that Na is the one electrode we were taking and Cl is another, that. Okay, so that deposition and other things, no, so same principle is there, but it is in the reverse way. We have to just remove the metal from the workpiece. Okay, no need to deposit on the tool. Okay, so it is called a reverse of electroplating. So when that electrochemical action is going to start, when you will start, or when the current will start flowing in between that, no, IEG, then and then only the electrochemical reaction takes place. Okay, and after that electrochemical reaction, or as a result of that, metal is going to remove from your workpiece, and by removing the metal from your piece, there you will get cavity, or that cavity will be formed in that workpiece. Okay, and that cavity means what? The cavity normally it is inverse replica of the shape of the your tool. Okay, what, in simple word, whatever shape you want to produce or you want to form on your workpiece, no, the same shape first you have to give to your tool. Okay, so by electrochemical that deposition or electrochemical reaction, you will get the universal replica of shape of your tool on your workpiece. Okay, so here the key words or keyword about this electrochemical machining principle is that electrochemical reaction or electrochemical combustion. Okay, so by this process you can machine any hard material. Okay, you can machine any hard material provided that, or the condition is that your workpiece should be electrical conductive. Okay, and depending on your workpiece, you have to select the appropriate electrolyte. Okay, now which electrolyte will be suitable to on which workpiece, that we have to go to learn in the chapter number 4. Okay, in that we have the types of electrolyte and all these things. Okay, but remember that here electrochemical machining process, it is useful for any hard material, but provided that it is electrically conductive. Okay, also it is the that whatever the work piece we are going to uh, take, for machining, so it should have the electric chemical property, because that chemical reaction is there, no, electrochemical, or their metallurgical property of the workpiece. Okay, so both this property will affect the performance of our process. Okay, rather than here we need metallurgic property, or we can call that another that chemical property. Okay, rather than the mechanical property of workpiece to consider, we have to concentrate on the our chemical property or metallurgical property. Okay, because depend on these properties, electrical conductive or chemical properties or metallurgical properties, so depend on these, your performance of this process is going to affect. Okay, and whatever the workpiece hardness is there, no, so that workpiece hardness is no more barrier in this case or in this kind of process. Okay, whether hardness is less or more than your tool metal, no matter, here no barrier about the that hardness. Okay, so because we have studied that in conventional machining process we have some barrier or limitation about the hardness, but here we don't have that limitation or barrier. Okay, so this is about the electrochemical machining, just overview. Okay, remember that this electrochemical machining process, it is totally a reverse of our electroplating. Okay, so in simple word, it is a reverse of electroplating. Now that how electroplating works, so we know that the Faraday's law of electrolysis, that also we are going to learn that time. Okay, electrolysis process and Faraday's law, and then we are going to move towards the electrochemical process. Okay, so whatever the setup that we are going to the, but here remember that the condition or the necessity of this process is that the workpiece should be electrically conductive. Okay, so that is important, because we know that you can see by figure also you will get that. Huh? Okay, and whatever shape you want to produce or you want to form on your piece, that shape firstly you have to give to your tool. So whatever will get the cavity on your piece, that will be a replica of your tool. Okay, now let us go for the another process. It is called chemical machining. Okay, chemical machining. Now in this process, normally etchant is used. Okay, now etchant means what? So etchant, which reacts chemically with your workpiece. Okay, and the another is a maskant. So maskant is used on your workpiece surface to hide that part of the surface from where you do not want to remove the material. Okay, once again I repeat, from your workpiece some part will be there. Okay, from that part, if you do not want to remove any material, then on that surface we have to uh, give the, or we have to place maskant on that surface. Okay, so maskant is used for workpiece surface to hide that part of surface from where you do not want to remove the material. Okay, and etchant means what? Etchant is a chemical, okay, that will react chemically with your workpiece part or surface, and wherever etchant will react off from that surface of your that part of your surface, the material will be removed. So remember what etchant and maskant. You can see here etchant is there, workpiece is there. On that workpiece we have on the top surface we have the etchant. That means from top surface of workpiece we have to remove the material, and the outer side, okay, outside of our workpiece, no, from that part we do not want to remove material. So I have put that masker, okay, or I have provided masker on that. Okay, so etchant and masker. Now for this chemical machining process we have the different steps, okay, and that steps we have to follow. Okay, that we are going to see in the chemical machining. Only steps are there, no another. Okay, first cleaning of the workpiece, okay, then etchant, then maskant layer applying. Okay, so whatever, and depending on that we have the which are the types of the, whatever the types of the that maskant technique are there, maskant applying technique. So depending on that we have the another process is called photochemical machining. Okay, so when we will apply the etchant and when we will apply that provide mask, no, after that we need to dip, or you need to immerse the workpiece in the etchant normally for a definite period of time. Okay, workpiece we have to dip or immerse in the etchant. Etchant means just chemical, and after some period of time, by etching action or the chemical dissolution, the by reaction of that etchant with your workpiece surface, the material will be removed. Okay, by chemical dissolution. So here mechanism is that of the word chemical dissolution. Remember that. Okay. Now that after immersing the workpiece in the etchant for the definite period of time, after that what will happen? The metal from your workpiece surface start dissolving chemically. So chemical dissolution action will start, and after certain period of time, you can take out your workpiece metal from that etchant solution, and you will find that the desired shape and size have been formed on your workpiece or your component. Okay, that means metal is removed from the your workpiece surface. Okay, from where you want to remove the metal. Okay, so this is simple overview of this chemical machining. Okay, got it. So up till now we have covered the mechanical energy based processes, that is the water jet machining, average water jet machining, then ultrasonic machining we have covered. Then we have gone for the electric discharge machining, then that laser beam machining, electron beam machining, plasma arc machining, ion beam machining. And today we have seen the ECM, and that is electrochemical machining and chemical machining. Okay, so now the combination of this electrochemical with our grinding machine, no, we have the another, that is electrochemical grinding. Okay, only the same process is there, but instead of tool we have to put our grinding. Okay, having the abrasive layer on its surface, that is called electrochemical grinding. Okay, and in this chemical machining, so whatever the techniques available for applying the maskers, no, in that we have the photo resistor technique, that is called photochemical machining. Okay, in that again we will see. Okay, now here in short I will take this or in brief I will tell you the machining methods for advanced engineering methods. Okay, whatever I have taught now, so just I will take the summary. So what are their application in general problem that we have discussed, okay, and we have find the solution, that is advanced machining process. Okay, now let us discuss some headings which are we have covered, which are we have discussed as a firstly we have discussed that what is meant by conventional machining method, and then we have gone for the advanced machining method. Okay, and in that we have seen that if there are electric conductive materials or metals and alloys having very high hardness, then it becomes very difficult to machine them by conventional machining method. So in some cases, work material hardness is equal or more than that commonly used tool material hardness. So in such cases, plasma arc machining, which is coupled with your conventional machining, is used to enhance the material removal rate as well as the tool life in your workpiece in your conventional conventional machining. Okay, and when you are hitting the workpiece with the help of plasma arc and remove the material with the help of conventional cutting, no? So that time that process is normally it is called hot machining, or it is also called hybrid machining process. Okay, I repeat, when you are hitting workpiece with the help of plasma arc and remove the material with the help of conventional cutting tool, that time the process is called hot machining or a hybrid machining, which is called hybrid machining process. Okay, and as we have divided the mechanical type advanced machining process like WJM, AJM, AWJM. Okay, so this process gives the normally low machining rate. Okay, remember, okay, whatever the mechanical type advanced machining process are there, no? So these processes give low material removal rate and low accuracy. And whatever the thermoelectric methods like EDM, EBM, plasma arc machining, then electron beam machining. Okay, so in that again, EDM is the most popular process among all these three, all these that thermoelectric non-conventional machining. Okay, so you will find that this process is used even in small scale industry in India also. Okay, so it gives low MRR, material removal rate. Okay, though it gives low material removal rate, but we will get good surface finish and good dimensional accuracy as compared to our other processes. Okay, now if we talk about the plasma arc machining, that is good for rub cutting machine, rub cutting purpose. Okay, and if you talk about the laser beam machining, so that EBM is becoming more popular than any other thermoelectric process. Okay, nowadays laser cutting is there, laser beam, all these things. Okay, and in case of last that electrochemical and chemical machining, if you talk, then in that, yeah, what are the ECM technique is there? So that is also another popular process because it gives the highest material removal rate in all advanced machining process. Okay, please remember this. ECM is the more popular process and it gives the highest material removal rate in all advanced machining process, except plasma arc machining. Okay, also it gives a good surface finish, but comparatively low dimensional accuracy is there. Okay, so these are the reasons why it is that that is plasma arc machining is not popular as if you compare with the EDM. Okay, so other problems which are associated with the tool design also there. So because of that, or because of which we are not able to get good accuracy on machining component using the plasma arc machining. Okay, so these are the just general ones are there. Okay, so when we will learn one by one process, that time we are going to cover all the points related to that process. Here we have covered the overview. Okay, and if you need any help regarding textbook, please refer this Advanced Machining Process by VK Jain book. Okay, in the study material, I have shared this link, that PDF and all these things, and this textbook also. Okay, I will share in our WhatsApp group also. Now let us discuss the last point of our chapter, that is comparison between our conventional and non-conventional process. Okay, and here I will cover the similarities also. Now, in this similarity and difference between conventional machining and non-conventional machining, let us discuss what about the conventional machining only. Okay, firstly we'll discuss what is this conventional machining. Once again, that repetition only, because we know that if you go by definition, machining means what? Machining is one of the secondary manufacturing process by which we can remove, or we can remove excess material. Gradually we can remove excess material by sharing from a preformed blank, okay, in the form of solid chip, using the edge shaped cutting tool, okay. And in order to get desired shape, we need that cutting tool, okay. And what are these secondary manufacturing process are them? So it follows the normally subtractive manufacturing approach, okay, to fabricate a desired object. And I will ask, what are the examples of conventional machining? Then answer will be that our turning, threading, facing, drilling, boring, milling, shaping. So these are the all conventional process. Okay, so such conventional machining process are normally they are unable to cope up with the ever growing demands of the miniaturized product with high surface quality and close dimension tolerance. So to get the advanced solution about this problem is we or we can call to overcome the limitations about this conventional method, we have to go with the non-conventional machine, okay. Now what is non-conventional machining? Okay, so in this non-traditional machining or advanced machining processes, neither sharing occurs nor chip forms occur, okay. So in fact this processes does not even utilize so-called cutting tool, okay. In non-conventional machining we are not utilizing cutting tool, okay. Whatever tool I have mentioned in EDM or ECM, these are the electrodes, okay. And the cutting tool like in our traditional way, no, so that is different. So here I have mentioned that such in non-conventional processes, such tools, cutting tools are not utilized, okay. And instead of that, only chemical energy or various forms of energy like thermal energy, electrical energy, then chemical, or the combination of these energy are used in direct form in such a non-traditional machining, non-conventional processes. For what purpose? To remove the metal. And the metal removal is also realized in several ways, such as that means the mechanism, such as that erosion action, then melting and evaporation, then ionic dissolution in case of the ECM, chemical dissolution, etc. So there are several non-conventional machining processes are there, like abrasive jet machining, ultrasonic machining, electrochemical machining, electro discharge machining, laser beam machining, etc. And such each process has its distinct capabilities, and these are suitable for specific purposes. Okay, remember that every process has its distinct capability and they are suitable for specific purposes. Okay, now here I have mentioned some similarities between the conventional machining and non-conventional machining. Okay, if you see in the slide, the first similarity is that so both conventional and non-conventional machining both are machining processes, and thus both are used for the removal of the material from your workpiece. So removing the excess material, for that purpose we can use both processes. The second similarity is that both are subtractive manufacturing process. Okay, that means it is called top-down approach. Okay, and also I have discussed that both are secondary manufacturing process. Also, both can produce sufficiently smooth and finished product, finished surface with close tolerance. Okay, although different processes have their different capability. Okay, so these are just general similarities. Now, the main important is that comparison between the our conventional and non-conventional process. Okay, so you can see here I have made two columns. In first column you will get the points about conventional machining, and in second column you will get the non points about the non-conventional machining. Okay, on each slide 1.1 will be there. Okay, now the first point about the conventional machining is that here only mechanical energy or mechanical power is utilized to remove excess material, gradually remove of the excess material from the work. So mechanical energy means what? We are using the edged cutting tool, okay, and we are giving the some force, okay. So due to that sharing, the material will be removed from the workpiece. So it is called only mechanical energy is utilized, okay, to remove the material. But in case of, if you see in the non-conventional machining, here various forms of energy like mechanical is there, electrical is there, thermal is there, chemical is there, the light, etc. Or combination of two or more than such forms of energy are directly utilized to remove the excess material. Okay, and depending on this domain of energy or forms of energy, we have divided the non-conventional machining processes. Okay, so that already we have studied the classification of non-conventional machining. Then second point about the conventional machining, that material are removed in the form of tiny sharper chips. That means the microchips are will be formed, okay, by while removing the material from the workpiece. Okay, so material are removed in the forms of tiny sharp. But so what are the chip formation in the, is there no in case of conventional? So such, so or so-called chip is not produced in case of non-conventional machining. Okay, whatever metal is there, so that metal is removed in various forms, such as tiny metal particles. It is called debris or craters. Okay, metal particle or ions is there. Okay, because chemical dissolution is there, then chemical dissolution is there, or ion dissolution in called. Also, in case of EDM or EBM, that uh, that our LBM. So in that process, melting and evaporation will be there. So that time, molten or vapors will be the forms of our removal of the metal. Okay, then uh, in this conventional machining process, normal shear deformation is the only phenomena that causes the removal of the material. Okay, please remember, the shear deformation is the only phenomena that causes the removal of the material in case of conventional machining. But in case of non-conventional machining, shear deformation plays an insignificant role in removal of the metal. Okay, in most of uh, non-conventional machining process. Instead of that shear deformation, we have the different cause like mechanical erosion is there, chemical dissolution, electrochemical dissolution is there, then melting and evaporation is there. In case of iron beam machining, we have the splattering. Okay, so etc. Occurs while removal of the metal in case of non-conventional. Then in case of in case of conventional machining, here a sharp edged cutting tool or sharp edge shift the cutting tool having specific geometry, having specific material and properties is required for cutting action. That is removed. Okay, and in case of non-conventional machining, so-called cutting tool, no, so that does not exist here. Okay, that does not exist here. However, in few cases, for example, which I have already mentioned, that EDM, ECM, their tool is required. Okay, but that is a electrode. Okay, so there is tool is required, which is not in physical contact with your work with. So that tool is required, and so whatever the profile and the property are there, so that must match with your requirement. Okay, that means whatever shape or the cavity we want on, or we want to form on our work, so same replica of that. First, we have to do it on our tool. Okay, in case of ADM ECM, in case of that also ultrasonic machining also, because they were given the mechanical vibration. Then in case of conventional machining, normally we know that physical contact is there in between your cutting tool and the workpiece. Okay, and also relative velocity in between them are necessary in order to remove the material. Okay, we know that. Okay, where if you apply the force to your tool, then and then only tool will apply force, that sharing force is there, no, on your workpiece, and then only material will be removed. But in case of non-conventional, there is no physical contact occur between your cutting tool and workpiece. Okay, in a few processes such as abrasive jet machining, abrasive water jet machining, or ultrasonic machining, solid abrasive glides or grains, okay, which are the, we can call that slurry. Okay, abrasive slurry. So that abrasive glides strike the workpiece surface to erode the material. Okay, to happen that erosion action, we are giving the abrasive slurry in between your tool and your workpiece. Okay, so that may be the your working medium. Then normally these conventional machining processes, so are age-old processes, and the physics of this process are well known, well understood to all we technical skilled person. So skilled laborers are also easily and readily available in the market, also at compared to cheaper cost with cheaper cost also. But the whatever the non-conventional machining are there, or most of these processes are developing. Okay, so for that labor cost is also very high. Okay, due to less number of skilled laborers available in this field. Okay, because uh, if you purchase the EDM process machine or the or PCM machine, or we can call ECM. Okay, that time, or laser beam machining also. Okay, that time we need skilled labor. Okay, who knows or who will be well understandable about that process. Okay, so that time the labor cost is also high because most of processes are in developing. Then in case of the conventional machining, it can produce a wide range of surface finish, okay, depending on the process that is employed. Okay, it can produce a wide range of surface finish depending on the process that is employed, and also the process parameters. So depending on that too, it can produce a wide range of surface finish. However, getting surface finish below 10 micron, no, okay, using conventional machining, it is quite difficult, and that requires costly CNC machine. Okay, if we want 10 micron surface finish or below that using conventional machining, then that time it is very difficult, and also to achieve that we require costly CNC. But in case of non-conventional machining, it is very easy, or whatever the surface finish is there. So whatever we achieve the surface finish in case of non-conventional process, so it is much better than that of our conventional process. So it can easily provide surface finish in nanometer range also. Okay, and to get that nanometer range surface finish, normally that whatever the process EBM are there, no, or EC, that we are using. What are our conventional processes are there now? So these are the processes are suitable for bulk removal of the material. Okay, or removal of the material in bulk. No? So that time non-conventional machining processes are suitable. Okay, in this sense, again there are these are fast, reliable, and economic. Okay, also we are getting the high material removal rate. Okay, using the conventional machining, but regarding non-conventional machining, so these are the suitable for highly accurate and precise requirements. So that time we can use our advanced machining process. For bulk removal of the material, these processes are time consuming, also less reliable and uneconomic. Okay, this is general. Then conversion machining processes. There are certain shapes that cannot be processed. It is called integrate shapes. So there are such shapes we cannot produce, can't be produced by using conventional machining. And using non-conventional machining process or not conventional machining, sometimes it become a reliable option for producing such critical or integrate shaped uh, workpiece. Okay. Now, what are the examples of the conventional and non-conventional? We know that about the conventional machining. Examples of the conventional machining process, we know the turning, facing, operation, or whatever process, I don't know, growing, drilling, or boring, reaming, shaping, or honing, milling. So these are our conventional machining processes. The next, what are the non-traditional machining processes or non-conventional? So we know that first group AJM, WJM, AWJM, USA. Then second group EDM, wire ADM. Then third, that is electrochemical machining, chemical machining, photochemical machining. Okay. Then laser beam machining. electron beam machining, ion beam machining, plasma arc machining. So these are the non-traditional, non-conventional or advanced machining processes. And also it is possible to go for the hybrid machining processes. That means the hybridization of these above process also non-conventional or also these are the non-traditional machining processes. Okay, so this is about the comparison between the conventional and non-conventional machining. So here I have shown, I have mentioned that some reference book also. So you can use this advanced machining process book, or you can use this unconventional machining process by T. Jagdesha or non-conventional machining by P. K. Mishra. All these three books or hard copy of these processes are available in the market. Okay. So here, in all respect, we have covered our first chapter of our non-conventional machining. Actually, only university has given 2 lectures for that job, but we have conducted I think five to six lectures. Okay. Next lecture, first we will take the one MCQ based test. Okay, about the chapter number 1, and then we will go for the our chapter number 2, that is unit number 2. Okay. If anybody want to draw this diagram, please draw, because I have not given the time. For better understanding, please, for just practice, please draw the diagram. Okay. Otherwise, what happen? I am just telling, or I am just giving the information. But if there is no response from your side, then it is very difficult to uh, understand you also as well as me, whether you are understood or not. Okay. Please draw this diagram. So simultaneously, what I will go first, what you can do, you can put your roll number in the chat box, okay, so that I can take the attendance. So 30 students has joined, but what about remaining present? Okay, please write down your roll number, all of you. Okay, those who have written, no problem. But those who have not written their roll number in chat box, please write down, because out of 30, only 22 students have given the attendance. What about other? Otherwise, I will not take attendance of that student. Okay, no problem. Okay, thank you very much.